as solving the equations, which you guys saw yesterday. Pretty simple to solve the equations with the imaginaries. You treat it the same way as like you would any other radical. You just have to make sure when you're simplifying out, you throw an I in it. That's about it. What we're going to look at today is how do you multiply with them? How do you add with them? How do you divide with them? How do you worry about simplifying fractions with them? It kind of mirrors the idea with the fraction as multiplying by conjugates like you did with radicals. You treat it the same way. And what you're going to wind up doing a lot of times is creating differences of squares. So hopefully this isn't going to be all that complicated, because it really isn't all that complicated. It's just kind of weird. Oh, I know what I forgot to show you guys. Yesterday in 12th hour, I took this, -4 plus 3i, I think it was plus or minus was the thing I gave them. And I wanted to show them, I'm not going to make you guys graph these things, but you know I always joke about graphing imaginary numbers, so I'm doing it right now. I thought I would actually show you how you graph them. It takes like 2 seconds. So this is what you do. Gee, what does that look like? A graph. So these are our x values, these are our imaginary values. What direction do you think I have to move that? -4. What direction do you think I have to move that? Up 3 and? Can we make this any more difficult?
Probably.
That's how you graph imaginary numbers. That's it.
But it's not imaginary, it's there.
I know, but now when I say I'm graphing that, now you can imagine what it looks like too. See, I'm helping you. You're welcome. Conjunction. Thank you. All right. So, complex, we're going to look at, I don't ever want to see you guys write down these long-winded, a pain in the butt definitions for what works out to be distributive property, what works out to be combining like terms, because it's pointless. Because you look at it just like that.
I know, I was doing the
when yet all this means is this. What if you had in parentheses 4 plus 5x plus -6 minus 2x? What would you do? Drop the parentheses because it's an addition, and you wind up with 4 plus 5x minus 6 minus 2x. So what would you do? Okay. Normally you guys, when you dealt with variables, you would put variables first. Agree? So you would write this as, 3x minus 2. Now, guess what changes with imaginary?
You don't write the x term first.
That's it. It's the same darn thing. If this was an imaginary number, and if this was an imaginary number, notice I treat it the same way, except at the very end, instead of putting I don't put the imaginary first, I put the constant first. -2 plus 3i. I combine like terms. That's the only change. When you have an imaginary number, it's last. That's it. That's it. Same thing goes for with subtraction. If you're subtracting terms, a lot of times they'll throw the complex number gets put into a parentheses, just like these 2 examples here. So if it was minus the junk, what would you have to do with the minus sign to the junk? Distribute. Exactly. That's it. That's all this is, guys. This is distributive property. Oops, I hate that button. It's the distributive property with imaginary numbers. That's it. That's all this is. All we are doing is combining like terms. You have all done this. None of this has ever changed. This is going to be ridiculously simple.
Is it our homework?
Pretty much. There will be a little bit of, there's a little, I don't want to say complex problem, but when we have to simplify a fraction, that's the only craziness that happens. Okay. So,
Dr. Evil when you say that.
you know, $1 million. So what's 4 plus 3?
7.
All right, pace yourself. -1i plus 2i.
Oh, whoa. Slow down.
I know. I'm sorry. Okay. Do I have? This is a real tough one to ask now. Do I have to put a 1 in front of the I?
No.
Yes.
If I did, would I be wrong?
No.
You're just wasting ink. Now, In the other one, this is scary now. I hope you're okay with this. I know. Be careful. Rewrite it. Okay. Distribute the negative. Whew. Now what?
Plus 5. Plus 5.
So what's your answer?
How'd you get
6.
plus 5? You're adding? But it says a negative 5 over there. Got it.
I'm glad you asked that question because some knucklehead in here would have done that wrong. So you were helping out others. Error 5. Weak error 5. You like missed it. Yeah.
You missed, how do you miss it?
Somebody missed an error 5 last year. Was it in your class? Somebody missed an error 5. I went up for an error 5 and they went sideways to an error 5. How do you miss a sideways? So anyway, take a second and do this one. I know. I have faith in you. Maybe a little, but I have faith. Some, yes.
Just distribute that, the 6 minus, you see the thing.
If it was negative 6, then negative 8 in front. You're overthinking. All it is that it's a 6 minus the 1. This Let's just go for services.
And they like remove all the
Yep. And you just bring the 6 down.
So it's just gonna be 6 plus 2. So it's like 6 minus negative 2.
Yeah. And then minus the negative, and then minus a positive 9. You're just distributing the negative. That's all you're doing here.
You're just doing that so you don't have to do the parentheses around it, so you don't have negative.
Because complex numbers are written with parentheses because they're grouped with that x and imaginary. It's grouped as an a plus bi. That's kind of how they write it out. That's why when we graph them, we do that. So you have what? 6 plus 3 minus 9 I minus.
Plus 2.
I was just checking to see if you're paying attention.
I don't know, it's like.
Minus 8, and then minus 4.
Wait, it's plus 4.
See, this is what happens. I write left-handed. I can't use my other part of the brain.
So then
6 plus 2 is?
8.
Minus 8 is?
0.
So negative 9 plus 4 is?
Negative 5. Wouldn't that just be, would it cancel out if it's negative? No, because like if an I is already negative, and it's just like I's like X.
Yeah. When you're simplifying these problems like this, Kelly, treat it just like a variable.
Alright.
You combine like terms just like you would any other variable, and don't overthink it.
I thought I was like a negative number, so that it tries negative.
I is the square root of negative 1, but when we're dealing with terms like this, all you're doing is just simplify. You treat it exactly like you would any other, like a variable at this point, okay? So don't overthink it. It quite literally is substitution and simplify. That's it, okay? Now, it does get a little bit messy when you have to worry about multiplying things through, because this is where
Negative 10i plus 5i squared.
right. But what we need to figure out then is that there becomes special patterns with the I squareds. Because I squareds can simplify themselves through, and that's where it becomes we have to be careful with. So again, we have 5i times the quantity negative 2 plus I. Distribute like you would any other problem like this. You get negative 10i plus 5i squared.
Wouldn't that be negative 5?
Hold on. Let's write out what I equals. What does I equal?
Negative.
The square root of negative 1.
equals the square root of negative 1. That means that I squared
Is -1.
would be the square root of negative 1 squared. So the square root of
just
junk
negative
squared
1?
is junk, which is negative 1.
So then if you square I, then it becomes -1, so then it's actually negative 10I minus 1,
Minus 5.
minus 5.
What about I cubed? I cubed would be I squared times I. I squared is negative 1,
So that'd be -5.
so it would be
Still negative 1.
I.
Negative 1. Wait a second.
All right, watch what happens. This is kind of cool. So I is square root of negative 1. Are we okay with that?
Yeah.
Yes.
I squared would be the square root of negative 1 squared, which is negative 1. Okay? I cubed would be is I squared times I. Everybody okay with me writing it like that? Remember the power rules when you can split things apart like that? So that means this is negative 1 times the square root of negative 1, which is negative I. Because the square root of negative 1 is I.
Isn't I to the 4th 1?
Yes. And then I to the 4th is I squared times I squared, which is negative 1 times negative 1, otherwise known as
1.
1.
Oh.
Your eyes just lit up like, what happened?
No, I heard it.
Okay. Now, you can continue this pattern through then. What do you think I to the 5th becomes? Square root of negative 1. Yep. That's the pattern. And it just repeats itself after that. Okay, it'll repeat itself after that because if you go I to the 5th, which is I to the 4th times I to the 1st, yes it will. This actually this becomes, I've seen this on ACTs before.
How?
What is I to the 27th?
I took the ACT and I saw stuff about eyes and I didn't know. I did the best on that.
I thought the ACT only went up to like geometry.
No, actually the ACT goes, I'd say about 70% or about 65% it goes up through geometry. The ACT though has a ton of polynomial operations, a lot of function notation, a lot of the trig stuff that I show you guys. So you guys, by the time if you take the ACT in the spring, you will see, I would say, almost 96, 97% of all the material that's on there. There are a couple of questions that I've seen in past years that have some probability to it. I usually try to get the probability, but it's usually the last couple of sections of the year. I have seen a couple of, no, that's on, yeah, that's about the only thing that's on the ACT that we might not see this school year. But you guys, I set you guys up for being ready for it really, really well, so I haven't had any problem yet, I hope. But yeah, what did I say, I to the 27th? If you do I to the 27th, all you gotta do is break that down into chunks. Think of it, that's I to the 4th, 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 that's what, 20?
Yeah.
I to the 4th,
I to the 3rd.
and then I to the 3rd, because all of these guys equal what?
1.
1, so I to the 3rd then is
-I.
negative I, so this simplifies to be negative I.
You can also say because it's multiple of 3.
Yeah, you can go that route too. But it's just another way to work itself through. What's wrong?
So it's
All you have to remember, and to be honest with you, if you remember these two, the rest of it is easy. Because then all you have to do is just write out, well, to the 3rd power is the same as squared plus 1. To the 4th power is squared, squared. 5th power is squared, squared, 1. 6, squared, squared, squared. 7, squared, 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 1, and so on. Okay? If you remember those patterns like that, you're gonna be, if you remember the first two, the rest of them just fall into place. All right? Yes, sir?
Can't you just get like understand the first 4 and then like let's say you get a number, just divide by like one of those 4 numbers?
Yeah. Works the same. That's what he was just trying to do. Works the same. It works exactly the same way. All right? I have seen that question before on an ACT, and it just breaks it down into that. Okay. So back to here, we had negative 10i plus 5i squared. Well, 5i squared is 5 times negative 1, so my final answer for this would be negative 5 minus 10i. That would be the proper way to write that. Okay with that?
That's what I changed it to.
Good, 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 good. Okay. What do you think you do here? Foil. Billy binomial again. Negative 7 plus 14i plus 4i minus 8i squared. Let's see, negative 7 and 18i, and then I have a plus 8 at the end. Why is it plus 8? Well, negative 8 times negative 1 is positive 8. And you're left with 1 plus 18i. You guys do the other one. This will work out.
Negative I squared.
This will
What
help
is-
us.
Negative I squared is just 1, because regular I squared is negative 1.
Where are you getting negative I squared?
Like, right there it says negative 8I squared.
Remember, this means negative 8 times I squared.
Yeah, and
I
I
squared
squared
is-
is equal to negative 1.
So what's negative 8 times negative 1?
8. So that's why I was, okay. If it was positive 8I squared,
And then it would be,
negative, that's what I was trying to say.
yeah, I wasn't sure where you're going with that because you were saying negative I squared with all, I'm like, huh? Yeah, that's how that works.
I was just trying to use it as an example, like making the coefficient 1 instead
Gotcha.
of 8. Can we get our homework now and start working on it with you here?
We're not done yet. We're going to do this one, then I have to show you multiply by conjugates. I think that's right.
Wouldn't this one just be negative 9 plus 36?
Well, if you FOIL it out, does everybody see how this works out?
9i.
Does everybody see how this works out to be a difference of squares?
Yeah.
Because you have a plus or minus the same values. So, will you have a middle term in this case? No. So it just winds up being 6 squared minus 9i squared.
36
So it's 36
plus 9,
plus 9, otherwise known as,
45.
there you go.
What happened to the I?
What's I squared? Negative 1.
Wow, how did we just get that?
So this, you're okay with the middle term, right?
Oh, yeah, I
All right, so this is 36 minus 9, and I squared is negative 1.
Guys, do you know how to do an I squared? Was it I just forgot.
You'll have to remember what, I is negative, the square root of negative 1, I squared is negative 1.
Wait a second. I thought that you were squaring the 9. And that's,
Nope.
wait a second. Then, wait, where did the 45 come?
36 plus 9.
Oh. I thought that was like your final answer. Like you got 36 plus 9 on one side and 45 on the other side.
Oh,
and then
yeah.
so I was like, what? How is that on both sides?
All right, so now what?
You gotta divide.
Did I write now as in know what? I did, didn't I? Hey, you know what? You know what? I don't know.
That makes sense.
It does. I don't know what I'm talking about. This is why I took.
This is why you take math as English.
Exactly.
That's really funny.
You should do English.
No.
I don't like Miss Favorite.
So one of the things you have to do, again, in terms of etiquette, I think I kind of hinted at this yesterday. When you're dealing with imaginary numbers, just like you were dealing with square roots, you never want an imaginary number in your denominator. So we're going to multiply by what's called a conjugate. We're going to do what we just did this last problem. We're going to multiply to create a difference of squares. I'm going to take and multiply the top and bottom of this by 1 plus 2i. Because if I multiply these two together, the middle term drops out. There will be no i's in the denominator. That's how you simplify these things through. You're going to multiply by conjugates. Okay? So I always like to deal with these one at a time. I'll take care of the numerator, FOIL it out. I get 5 plus 10i plus 3i plus 6i squared. And then I do the same thing with the bottom. 1 minus 4i squared. Knowing that minus 4i squared is the same as 1 minus 4 times negative 1, I know now my denominator is 5. My numerator then, I get 5 plus 13i, and then what's 6 times I squared? Negative 6, very good. So my last step then is to combine the 5 and the negative 6, and I get negative 1 plus 13i all over 5, and I'm done. That's how I would simplify that through. Julie, what do you got?
At the bottom, we got 1 minus 4 times negative 1. How did you get 5? Because this is the multiplication.
This
Multiply
becomes
negative 4 by negative
1. This becomes 1 plus 4 then.
Yeah, 1 plus 4. Oh my god. Wow.
You know, it was raining out this morning. It's okay.
I got how you even got the negative 4. I mean the plus.
Wait, can you go back? Can you go back?
Oh!
I wasn't ready. I'm scared.
Yeah, Emma.
Everybody's looking at you.
Yeah,
That
Right
was
faster.
and right faster. Nice job, Emma.
Thanks, sir.
So, let's see. I want to do another one of those. What am I going to multiply top and bottom by?
1 minus I.
1 minus I. Remember, it's always the same values with the different signs. You're creating a difference of squares. So I have 3 minus 4i over 1 plus I. I got to multiply top and bottom then by 1
Minus I?
minus I. Very good. In doing this, I am eliminating that middle term. I'm eliminating the I, the imaginary number in the denominator, and then I just FOIL stuff out.
This is just over 1. Just over anything.
Oh, careful. So this is 1 minus I squared in the denominator, which is 1 minus negative 1, which is 2. So my denominator is 2. My numerator then, I just have to FOIL out and combine my terms. I have 1 minus 3i minus 4i plus 4i squared.
Okay.
I'm going to bring this down here so I'm a bit more space then. So that leaves me 1 minus 7i, and then what's 4i squared equal to? Negative 4, very good. Which then gives me the final answer of, bless you. Well, it's not the answer, but. And you're done. Just like we did earlier, if all three of the numbers, what? Yeah, hold on. What is screw up?
Yeah, wait, wasn't it 3 minus 3i?
What did I screw? It was 3 minus 3i minus 4i plus 4i squared.
1 minus 3i minus.
So 1 minus 7i squared, and then it was minus 4.
Oh, up there is 1.
Oh, thank you.
Yeah.
Sorry.
So
Is that
then-
better?
Yeah.
So then it becomes -1 minus 7i all over 2. Sorry about that. I was looking at the wrong number when I wrote it down.
Screwed that up.
The stuff that we work through on these things, it's not that it's going to be horribly difficult. It's just a matter of, don't forget I squared is -1. That's really all there is to this. I want to make sure I wrote down. I think I put this on the calendar already, didn't I? Did I?
I don't know how many.
Did I or did I not? I did not put it in the calendar. I thought I did. All right, let's do some problems in here. Let me see what I had. Make sure this is what I want to do here. I think this is right. Let me double check in my book to make sure. I believe those are the correct numbers. Hi, how are you?
Wait, isn't that, we didn't do page 276?
Yeah, but we did 20.
Yeah, but you didn't get through all of them. You didn't do. This is the other part. You know, the adding, multiplying, all that kind of stuff.
That's fine.
It is fun. Yeah, these are what I want you guys to do. All right. Work through those for tonight. I mean, we could probably quiz tomorrow, but yeah.
But I don't
Yeah.
know if he's gonna.
I think we'll still do it on Friday. All right, we'll still do it Friday. Okay. Yeah. All right. Yes, ma'am. Yeah. I'll put it up here for you guys. I'm gonna start. Hey, look at that! All fit on one page. Yay.
Oh, it's definitely